Today's goal is to learn what an identity is and learn some strategies that will be helpful in order to prove them. So for starters, what is a trig identity? A trig identity presents itself like an equation, as in our first example here, where it says to establish the identity 1 minus sine theta divided by cosine theta is equal to cosine theta divided by 1 plus sine theta. But what we aren't asked to do is we are not asked to find specific values of theta that work, as you would be doing with an equation. Instead, you're proving that this statement is true for all values of theta, or at least for all values of theta in which the left and the right-hand side are defined. So it's like a little mini proof. You're told that the left and the right are equal, but you need to justify it. You need to show it, usually algebraically. So what I'll do here in this video is I'll show you how those steps present themselves on Desmos, and then I'll have a separate little video where we can kind of focus in on the algebra and fine-tune exactly what the good strategies are in order to establish the trig identities. So let's look at example 1 first. Example 1, the left-hand side was 1 minus sine divided by cosine. So I'll look at a little graph of that here. As you can see, it's a nice little asymptotic thing, looks a little like tangent or cotangent. And the right-hand side of the equation was cosine x divided by 1 plus sine x, so I'll highlight that here. And you can see that the two graphs lie right on top of each other. That is, they are one and the same for all values of x for which they are defined. You can also see here in the graph that there's some sort of asymptote happening here at negative pi over 2 and another at 3 pi over 2. So the left and the right are not defined there, but everywhere that they are defined, they are one and the same. So what does it mean to establish it? What it means is through a series of steps, and these are algebraic steps usually. I'm just keeping the graphs here to show that the steps don't change things. Through a series of steps, take the left-hand side and modify it, manipulate it until it turns into the right-hand side. So let's do this. I'll turn the last one off for a second. I'll take the first expression here and copy it down into field 2. And here's a change that I could make that actually wouldn't change anything. It would just make it look a little different. I could multiply by 1. Multiplication by 1 is a great idea when establishing a trig identity. But the key is that you choose the 1 carefully. Just multiplying by a plain old 1 won't make it look any different. But if I were to say multiply it by x over x, now the expression's starting to look a little different. 3x over 3x. And while the expression's looking different, you notice that the graph is still looking exactly the same. I could also maybe multiply by cosine x over cosine x, and that'll change the way the expression looks. Keep the graph looking exactly the same. What's a good 1 to multiply by? In this case, a good 1 to multiply by might be 1 plus sine of x divided by 1 plus sine of x. And at first, that might seem like an odd choice. 1 plus sine over 1 plus sine. What that's going to do is that's going to make a nice little change in the numerator of my expression here, and I'll show that in the next line. In the denominator of the expression, I'm going to get just cosine of x multiplied by 1 plus sine of x. I'll leave the denominator exactly the same. In the numerator, I'll have a difference of squares. 1 minus sine times 1 plus sine. That's going to make 1 minus sine squared of x. And as you can see, after I add my parentheses here, it's the same looking graph all over again. 1 minus sine squared is the same as 1 minus sine times 1 plus sine, so I didn't actually change the values of the expression. I just changed the way the expression looked. In the next step, what I'll do, if you're not seeing the path just yet, is I'll take that numerator and I'll re-express it in another familiar way. And this brings up another really good idea that we can always use when we're establishing new identities, and that's rely on old identities. One identity that you knew probably before you pressed play on the video was that sine squared plus cosine squared was always equal to 1 for every single value of the angle. Well, here in the numerator I have 1 minus sine squared, so I can replace that with a cosine squared, because they would be one and the same. I would use my Pythagorean identity there to replace in the numerator. And now you're starting to see that that right-hand side, that goal that we were trying to reach of cosine x divided by 1 plus sine x is well within our reach. The last algebraic step that we should show is that the numerator, cosine squared, is really nothing more than cosine of x multiplied by cosine of x. And of course, now you have a factor of cosine of x in the numerator that can cancel with a factor of cosine x in the denominator, leaving you the desired result. And that's how you establish an identity. Of course, when you're establishing identities, you're really relying on the algebra and not the graphs. But Desmos is helpful if you're ever unsure if there's an algebraic step that you did, if it was correct or not. You can show it graphically, and the graph will confirm your intuition, or maybe point out some flaw in your thinking if it actually changes the expression, which would be a bad thing. All right, let's look at our second example. Our second example was to establish the identity cotan squared multiplied by cosine squared is equal to cotan squared minus cosine squared. That's kind of an unusual identity. Sounds strange. Sounds a little hard to believe that the product of these two squared trig functions is the same exact thing as the difference of the two trig functions. So once again, I'll look at it on Desmos here. I'll look at the left-hand side, and I'll look at the right-hand side. And I can see that the two graphs are one and the same. And this reminds me that the starting point when you're establishing a trig identity, it doesn't always need to be on the left-hand side. I could, in this case, I could start with the purple graph and work my way to the red, or I could start with the red and work my way to the purple. Either way is fine. In this case, I'll start on the left. I tend to start on the more complicated side, and in this case, really either one would be appropriate. So, okay, cotan squared multiplied by cosine squared. How do I get this started? What could I try to do to manipulate the expression cotan squared multiplied by cosine squared? And sometimes that's the hard thing in the beginning, is what ideas do you have? Should we be multiplying by 1? Should we be factoring something? In this particular case, neither of those seem like they're going to be a productive path because you're starting with multiplication and you're ending with subtraction. So what I might try instead is one of the ideas that came in example 1, and that's that you can use known identities. We know that for all values of the angle, sine squared plus cosine squared is 1. And that means that cosine squared is the same as 1 minus sine squared. So I'll sub out cosine and put in sine in essence. And I can see that I didn't change the graph at all, which is a good thing. In my next step, I need another idea, another algebraic idea. And I think the first thing that comes to mind for most people would be, hey, you should distribute this thing. Why don't you distribute cosine through to each of the terms? Cotangent. Cotan squared multiplied by 1, cotan squared multiplied by sine. So I'll try that here. Cotan squared multiply, you can see the graph changed on the right there as I was typing, because I didn't quite finish my typing there. Cotan squared multiplied by 1 is cotan squared, and cotan squared of x multiplied by sine of x, need some parentheses I guess here for Desmos, make it happy. There you go. Cotan squared times sine of x. Well, what is that? What I can see now at this step is I'm getting very, very close to the goal, the right-hand side. Cotan squared minus cosine squared. I have my cotan squared in place. I've got my minus sign in place. But I have this product that needs to be worked out. Cotan squared times sine squared. So I'll focus my efforts in there. And I'll just think, well, what do I know about cotan squared? Cotan squared is it's a ratio itself. It's cosine divided by sine. So let me rewrite it that way. Cosine squared of x divided by sine squared, that's not how you spell sine, sine squared of x. Just like that. Yeah, that'll do it. And now I can see that the sine squared that's in the numerator here and the sine squared that's in the denominator there will cancel out, leaving me cosine squared, and the identity is established. Check back to the second part of this video where I'll do a couple more examples on the whiteboard back in the basement again, so you can see a few more